Alright, welcome back to another video on the Maths channel. It's your teacher Muslim here. In this video we're going to be looking at scientific notation and significant figures. So, by the end of this lesson, you'll be able to write numbers in scientific notation, round numbers to specify the significant figures, and enter and read scientific notation on a calculator. So, first up, writing numbers in scientific notation. Scientific notation makes it a lot easier to compare really big and really small numbers. So for example, which one is bigger in question A and which one is bigger in question B? Maybe pause the video and have a go with this one yourself. Alright, so in question A, we can see here that the left one has more zeros, so this one is bigger. Right, so it's got 3, 6, 9, 10 zeros, and the right one only has 3, 6, 9 zeros. And in question B, we can see that the right one is smaller because it's got less zeros. Right, 3, 6, 9, 10, 11 for this one, and 3, 6, 9, 10 for this one, so that one is bigger. Now, how did you do that? Right, of course we had to count the zeros, which is really annoying. That's why we like to use scientific notation. Okay, scientific notation makes it a lot easier to compare really big and really small numbers. So here, question A, we've got really big numbers. If I were to use scientific notation, this one here on the left would be 8.7 times 10 to the power of 3, 6, 9, 10, 11. And this one will be 8.7 times 10 to the power of 3, 6, 9, and 10. Right, so that makes it nice and easy because we can see that 11 is definitely bigger than 10. Or for question B, we can see that this one here is 1.3 times 10 to the power of negative 3, 6, 9, 12. And this one here is 1.2 times 10 to the power of negative 3, 6, 9, 10, 11. And minus 11 is bigger than minus 12. So we know that's bigger. Right, so that makes it nice and easy rather than having to count. Now, a number is written using scientific notation is always in this form, a times 10 to the power of m, where a is a number between 1 and 10. Okay, it's not 10, it has to be less than 10, so it's a single digit. Okay, well, not single digit, it has to be 1 point something or 2 point something, whatever. It can't be 0 point something. It can't be 10 point something or 11 or 12. Okay, it has to be a single digit point, whatever. And that single digit cannot be 0. And this m here is an integer, okay, a whole number. It could be positive or it could be negative. Okay, so if it's positive, that means it's really big. If it's negative, it's really small, so really close to 0. So here's some examples, right? We got 8, 5, 3, and 1, 2, 3, 4, 5, 6, 7, 8 zeros. Right, we got 8 zeros. So if we put the non-zero digit and then the decimal, so 8.53, we can see here, we've put the decimal here, it's actually meant to be over here. So we need to move this decimal to the right 10 times. 1, 2 plus the 8 zeros, that's 10 times. That's why this has a positive power of 10, because we're moving it to the right. Whereas for B, 0.1, 2, 3, 4, 5, 6, 7, 8 zeros, and then 7, 9. If we move this to here to make it 7.9 times 10 to some number, well, we need to move it to the left because we've put it here, but it needs to be all the way over here. So we need to move it left. So because we're moving it left 9 times, 1 plus the 8 zeros will be to the power of negative 9. Okay, so that's how we do this. So write the following numbers in scientific notation. So here we've got 38 million. This is equal to 3.8 times 10. So it's always one digit and then a decimal. Just remember that digit cannot be 0. So 3.8. Well, the actual decimal is over here, so we actually need to move this decimal that we just put in to the right. And we need to move it to the right 7 times, because once to the right will be to the right of 8, then 3 and 3. So we need to move it to the right 7 times, and that's why it's 3.8 times 10 to the power positive 7. What about in question B? 0.000429. Well, we can't have 0 point something. So the next non-zero digit is 4. So we're going to put the decimal here. 4.29 times 10 to the power of something. Now we put the decimal here. It needs to be over here on the left. So we actually need to move it left. Okay, so it's always where do we put it to where should it be? So we're moving it left 4 times. Right? 1, 2, 3, 4. So it'll be to the power negative 4. Negative tells us it's left. Maybe pause the video, have a go with questions C, D, and E, and then we'll go through these together. Alright, so for question C, 3.186, we don't need to do all the other zeros, right? Times 10 to the power of, well, we put the decimal over here. Circle where we put it. It's meant to be over here. So put an arrow to where we want it to be, where it's meant to be. So we're going to the right, so it's going to be a positive number. 3, 6, 9, 10. Positive 10. We need to move it to the right 10 times. Question D. 9 point, circle where we put it in. 9.267. Draw an arrow to where it's meant to be. Oh, we're moving left, so this needs to be times 10 to the power negative something. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9 to the power negative 9. Alright, and question E. The land surface of the Earth is approximately 153,400,000 square kilometers. Express this area more conveniently by using scientific notation. So I'm going to put the decimal here. It's meant to be over here. It's a whole number. Moving it to the right, so it's going to be a positive power. So we've got 1.534 times 10 to the power of 2, 3, 4, 5, 6, 7, 8. I'm just going to put in my units, square kilometers. Alright. This time we're going to express each of these scientific notations as an integer or as a decimal. So, in question A, we are multiplying by 10 to the power 5. Because that's positive, we're moving to the right. Right 5 times. Well, we go to the right twice, it'll be 268. So we need to go to the right 3 more times, so that's 3 zeros. Question B, we need to move left 2. So we move left 2, that'll become 1, 2. That's where the decimal needs to go. In the empty spot, we put a 0. So this is going to equal to 0.090137. In question C and D, maybe pause the video and have a go with this one yourself. Alright, question C. We're going to move it to the right 4 times. If we move it to the right once, we'll get 10. So we need to move it to the right 3 more times, so 3 zeros. In question D, 8.337 times 10 to the power negative 7. We need to move it left 7 times. If we move it left once, it'll be over here. So we need to move it left 6 more times, so that's 6 zeros. So 0.6 zeros, and then 8334. Just like in this one in question B, If we move it left once, we'll be here, so we need to move it left one more time, so that's 10, 0.10, then 90137. Alright, so now let's have a look at part 2 of this lesson, rounding numbers to specify significant figures. Now, significant figures are used to specify the accuracy of a number. So, we need to be aware of all the different scenarios. Okay, if the number is 0 point something, then every digit is significant except the 0 before the decimal point and any zeros immediately after the decimal point. They are not significant. So, for example, 0.0012 has two significant figures, and they are these two. Because the 0 is not significant and any zeros immediately after the decimal point, not significant. So this just has 2. With question B, has 4 significant figures. These are the 4. Okay, the 0 before the decimal point is not. Any zeros immediately after the decimal is not. So 8090 has 4 significant figures. Pause the video, have a go with C, D, E, and F. Right, question C has 1, question D has 3, E has 2, F has 3. Let's just highlight them. That's significant. These 3 are significant. These 2 are significant. These 3 are significant. Alright. Now, if the number is a normal number with a decimal, okay, so not 0 point something, but for example, 13 point something, or 8 point something, or minus 6 point something, then every digit is significant, except any zeros at the start of the number, because we never write numbers like that. It's very silly to do so. So, for example, question A, 70.0, all of them is significant. 3 significant figures. B, all of them are significant. It has 5. Question C, we never write numbers like that. We would normally just write it as 10.82. So actually this only has 4 significant figures. Again, in question D, we'll never write 640.00. We would only write 640.00. So this one has 5 significant figures. Alright, and then the last one, which is quite tricky, is if a number has no decimal point, so it's a whole number, there could be more than one answer to how many significant figures there are. Any zeros at the start are insignificant, again, because we never write it like that. But any zeros at the end might be significant. So write every possible answer. So we have a look at this one here. This one definitely has 3 significant figures, but it could have 4, or 5, or 6. Because we don't know whether it's been rounded to the nearest unit, to the nearest 1, to the nearest 10, to the nearest 100, to the nearest 1000. We don't know. So it could be 3, 4, 5, or 6 significant figures. So if we have a look at question B, we can say for certain that there are at least 5 significant figures. Right? There could be 5 significant figures, but we can see here that it could be 6 and it could be 7. We're not sure. 5, 6, or 7. In question C, we never write it like that, right? We never write a 0. So, how many significant figures does it have? Exactly this many. 8. Okay. Question D, we never write numbers like that. So just ignore those zeros. 29,000 definitely has 2, but it could be 3, it could be 4, and it could be 5 as well. So we're going to say it's 2, 3, 4, or 5. Alright, so let's now combine scientific notation with significant figures. I might refer to this as sig figs because that's how I learned it when I was in high school. Okay, significant figures, sig figs. So write these numbers using scientific notation and 3 significant figures. So what I like to do first is actually write it in scientific notation and then round it to 3 sig figs. So I'm going to write this in scientific notation. This is equal to 2.183 times 10 to the power of 6. Now, this here only has 4 significant figures. This here is 4 sig figs. What are the 4? It's this. When we're talking about scientific notation, we are only talking about this that's considered significant. We don't really care about this. So because it's got 4 and we only want 3 according to the question, I'm just going to round it like a normal decimal. I want 3 digits. So 2.18, or is it 2.19? Well, that 3 tells us it's just 2.18. So 2.18 times 10 to the power 6, and that's the answer. And question B. I'll do this one with you, then you can have a go with A to D by yourself. So we've got 1.9482 times 10 to the power of negative, we'll put it here, we need to go here, we need to go left 3, so it's minus 3. But we can see here, there's actually 5. There's 5 sig figs here. We want 3. So we want it to say 1.94 or 1.95, or the 8 tells us 1.95 times 10 to the power negative 3. And that's 3 sig figs. So, have a go with A, B, C, D. Okay, write these numbers using scientific notation and 4 sig figs. Pause the video and have a go. Alright, so here are my answers. Question A, scientific notation in 4 sig figs is 5.709 times 10 to the power of 8. Because here we can see we only have 5. We have 5 significant figures. We only want 4. So that 9 tells us that the 708 is going to round up to 709. And question B, 6.2984 is 5 significant figures. We only want 4. So this 4 tells us that this 298 is going to stay at 298. Question C, we've got 5.21067 times 10 to the power negative 4. Well, this actually has 6 significant figures. So 1, 2, 3, 4. We only want 4, so we're going to look at that number. That number tells us that the 210 is going to round up to 211. Question D, we've got 8.999531. That's actually 7 significant figures. We only want 4. So 1, 2, 3, 4. We look at the 5th number. That tells us this 999 is going to round up to 1000. Now, do not write 8.1000. Because now this is actually 5 significant figures and it's actually wrong. Alright? Because 8.1 is actually less than 8.999531. Okay, we need to round up. So that, think of it as 8,999 becomes 9,000. So 9.000 times 10 to the power minus 7. Okay, so let's have a look at the last part of this lesson, which is just entering and reading scientific notation on a calculator. So here we've got 4 times 10 to the power 5 times 3.5 times 10 to the power 4. If you want to, you can use this button here. Okay, 4 times 10 to the power of 5 times 3.5 times 10 to the power of 4. 1.4 times 10 to the power of 10. Okay, so that's probably the easiest way. If you want to, you can just write 4 times 10 to the power of 5 times 3.5 times 10 to the power of 4, and then you get the same answer. Okay, now I know here there's brackets. If they're all times, you don't really need to type the brackets, but if there is a division or there's a plus sign or whatever, maybe it's best to play it safe and just use brackets. So for example, let's just do, I'll do C with you, and then you can pause the video and have a go with the other questions. So here we got division, so I might just do that. 9.6 times 10 to the power of 9 divided by 1.6 times 10 to the power of 4. Okay, so the times 10 to the power of is down here where pi is. Oh, I should have put that in brackets, so let's put that in brackets. Alright, and it gives us 600,000. Now let's write this in scientific notation. So this is equal to 6 times 10 to the power of 5. Okay, because we put the decimal here, 6.025. But no need to write 0.0. Alright, so why don't you pause the video and have a go with B, D, E, and F. Okay, so here are my answers. Question B is 2.814 times 10 to the power of 7. D is 2,625. E is 9.2016 times 10 to the 32. And F is 18,321.39, and I just rounded that to 2 decimal places. So, that's it for this lesson. Let's have a look and recap what we looked at. Okay, so we looked at how to write numbers in scientific notation and why we even have it. Okay, we looked at how to round numbers to specify significant figures. So 0 point something or some other number point something, or if it's a whole number, how many significant figures is it or does it have? And we also looked at how to enter and read scientific notation on a calculator. So if you found this video helpful, please give it a like. If you have any questions, please comment down below and I'll get back to you as soon as I can. And if you would like more content, please subscribe to my channel. I hope you have a good day, and I'll see you in the next video. See you.